Let's take a look at number 44, wildcard matching. We are given an empty string and a pattern. We need to implement the algorithm that detects whether the pattern matches the string with the entire input string, not partial. There are two special rules. This question mark matches any single character, and this asterisk matches any sequence of characters, including the empty one. So actually, we have done a similar question, which is the implementation of a regular string matching, and we can do the similar solutions for this one, I think, which is very simple. We're using the recursion for this kind of problem. Let's say we just take the first character, and check them. If they are equal, like AA, or a question mark, then we can match the second one. If one of them is asteroid, we first think this asteroid is empty, so match this one and this one. Do it recursively. If this does not match, we start matching this one and this one, which means take the asteroid as the first with the length of 1 and then length of 2, and do them recursively, and finally get the result, which actually is pretty straightforward. Let's check it. So we'll create the recursion function, which is match. We don't need to take out the string, so we just use the start index. So how this ends? It ends at, because we have to match the entire string, so it ends when I is bigger than when the string of s ended, or j is bigger than p length. If this is reached, we return true, right? If not, we will check if si, if it's equal to pj, or pj equals question mark, that means the first letters are matched. We return match I plus 1, j plus 1. If not, we check if pj if it is asteroid. If it is, we will try match this asteroid with length of 0 with 1, which means that yeah, for let k equals I, yeah, that's equals I, k was smaller or equal to s length, right? We're checking that. K plus plus. Yeah, if match them, if it matches k and j, yeah, then we return true. For all the other cases, we return false. Now finally, we return match 0, 0. Let's have a try. So actually it's done. Let's take a look at this input. Oh, there's a problem. Maximum call stack. Let's console log. Wait a minute. It will end. Aha. It will. We should return true, but I might exceed the length of I. The DS. In that case, if it is over exceeded, then the I will be bigger and bigger. If this time the J is equals to star, if PJ is, oh no, I don't know, let's log the IJ. One, 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 one. 0, 1, 1. So K equals I, and match KJ. If it's true, yeah, if we do this, we will check it again. So this is not cool. If we try, if next one is star, we should match. Oh, my bad. It should be J plus 1. Yeah, it is J, because this one should be J plus 1. Yeah. So yeah, this one seems to be acceptable. But after I submit, it actually gives us the problem. Wait a minute. Empty and the question mark, it outputs true. If I so I need to check here, check that if S exists, so S smaller than length. Let's submit again. Yeah, actually, when I use SI, it's overflowed. It's overflow. It's time limit exceeded. It means our solution is not wrong, but actually it's not very performant. Let's need to do some improvement. First, I will analyze this problem with this error case. So for this kind of input, one characteristic I can see is that there are multiple asteroids in a row, right? So actually, because the asteroid can match any sequence of length, like empty or any character. So this sequential asteroid is meaningless. Actually, they are the same. This is actually the same as one asteroid. So the first improvement is that here, for this case, in this for loop, we're matching A asteroid, and then we're trying to make the A asteroid, and then A asteroid. It doesn't matter. It doesn't help. So each time we met a character with an asteroid, we match A to the next character of this pattern that is not asteroid, which means skip the sequential asteroid. So while pj equals asteroid, j plus equals 1. This of course does not solve the problem at all, because it's still time limit exceeded. We need to add that. It says we're given the wrong answer. Oh yeah, God. We skipped too much. Yeah, it's time limit exceeded. So our case become like this. So if we simplify this problem, it's gonna be like a string, a very, very long string, and a very, very long pattern. If we simplify the pattern, we would be like asteroid AA, asteroid BA, asteroid A, asteroid BB. Like suppose we have matched to some pattern. It's like we are trying to fill the pattern with enough characters, right? Like replacing these asteroid into some string. And now we get one AA, and fill this with some random string, and find the next BA star. Yeah, CC A, some string BB. Yeah, our algorithm is actually like if we met this asteroid, we're trying to match AA, and then AD. This does not match, so we will match DA, not match. So we will finally find the first AA match here, right? And then try match DS. When DS comes, we will jump into this for loop again. We'll try to match DB, right? And because there's no D, this does not match, SB, AB, DB. Finally, we'll find this BA and got this D asteroid and go to DA. So if it goes well, it'll finally go to the last, right? The one problem is that it does not match. It might not match at the end, like BBA. For that case, because we're using in the recursion, this error will just propagate to the first match here, right? Because it comes at the problem of this match. AA matched, but actually D asteroid does not match at all. In that case, we will continue check this AA. But here's a problem. Let's say there is a possible. Okay, so this match. If this match does not, I mean, if the strings after this AA does not match the pattern after this AA, even if we find some AA in the later somewhere like here, even we find another AA here, it won't match. Why? Because our asteroid can match any string, right? Yeah, if this one match, then actually this one would also match, because this asteroid could match everything, yeah, including this AA. Yeah, which means if we find this AA cannot satisfy our needs, then we can stop this. We can stop searching the next possibilities of AA. It doesn't matter anymore. So let's wrap up a little. If we find this AA again, if we find this AA does not satisfy our needs, this AA is still won't gonna satisfy our needs because the asteroid here, this asteroid here would match all the possibilities. Like if you have a BA here, right? Like DD, like something like this. If this A doesn't match, then this asteroid, if this matches, then this asteroid could match all the string between this one and this, then this one, like match this one. So we don't need to find another duplicate string. That gives us the hint that for this recursion, we actually could return more results from simply true or false, right? The true means there's a solution. The false means there's no solution. But there's another thing, means that if it started with a match of asteroid, I mean, if we are handling this AA match, if we are already matched, which means another asteroid is met, then we could skip this AA check. It's to be exact, it will be in this for loop, right? Because for this AA match, this is some of them that is true here. But when we are checking the rest, if they tell us that some of them already checked the asteroid, then we can stop checking the for loop. We won't need to check the AD or AS anymore. We can just skip. How can we detect that someone is matched the asteroid? It's simple, because for each recursion there's only if this case or this case and the rest. The rest is false. It's the same. But for here, it's also return false. But now, since we have the conclusion, we can return something else here, right? Yeah, let's do that. So let's suppose that true use 0 to means true. And here, so this needs to be checked as if it equals to 0. For the other case, it's false, so it should, let's say it's 1. 1 means false. And here, now we need to check it's the state of these results. So let's say const result equals, this is the match. If result equals to 0, it's true, then we return true, right? Else if result, if it is equals to, okay, let's say false means -1. So if one means that it starts with an asteroid. So if the result is asteroid, which means here we return asteroid, which means it starts with the asteroid, but it does not match the whole string. It tells the previous recursion loop, the parent, the caller, that you don't need to continue anymore. I tell you that there is gonna be no solution. So if it is false, if this 1, if it starts with asteroid, we can just break. We don't need to check the other way. Check that the other iterations. Coming back to this example, which means that if DS doesn't match, then there's no need to check again of this AA. Yeah, it's gonna not solve our problem. So yeah, it's done. Let's check it again. Yay! Our solution is accepted and it's fast enough. So what is our time complexity? Let's take a look at our example here. actually, if there are more asteroids, it will help us make the problem simpler. So actually, the most difficult part, I think, it should be something that is not a match, but we cannot skip. We could have to check it once and once again. So it must be start with an asteroid, but the other only one asteroid, and the other elements will match, but at the end they don't match. So I have to loop them all over once, over and over again. So I think the worst case something like this. No, you have to start with one asteroid, and these are all A. Something like this, and so it's first is asteroid, so we check this, match. At the end, they don't match, so I have to check again, match. Okay, they don't match. Okay, and then again, match. Okay, they don't match. So what's the worst case of time complexity? So time complexity, worst case, it would be that this net would check every time, right? At the end will be something less than the length of p. Let's say the length of S and P is m and n. So it's actually with the length of m minus, with these 4 extra checks, it actually is m minus n times n, right? And plus the other case would be m minus n plus m minus m minus 1 until 1. So it actually would be m minus n plus 1 times m minus n. So it actually is m o m square let's say it should be m minus n times m minus n yeah, this is actually it should be plus 1 and divided by 2 plus m minus n. So it actually equals to here is m wow, I did a lot of math, man. Plus m minus n divided by 2 plus m to square. So it's actually O m to square. This will be sum up to 0, so it will be n to the square divided by 2 plus m minus n. Well, it's generally like this. Yeah. So yeah, that's all for this problem. I think for this kind of problems, what I need to do in the future is that always do it in the recursion first, like the time limit exceeded solution. It will always be robust and it will always be a valid solution, but it's not fast enough. And then we try to analyze the problem and find some unnecessary, search for the unnecessary checks and ignore them. So the pattern we can deduct from the problem always results from the samples we can get. Like leetCode gives us some the cases when the time limit exceeded happens, like the pattern we wrote here, and we can analyze the first that the sequential asteroid does not help anything, and then actually we can skip the checks of this for loop in a faster way. Yeah. Anyway, so that's all for this problem. Hope I can you can learn something. Hope we can learn something, and see you next time. I found that after doing a lot of videos, I became better in the algorithm world. Actually, I'm not very good at algorithm, and I'm just trying to be a better engineer. So yeah, I hope we can study together. See you next time. Bye bye.